Okay, Rishita, you are grade 11B, I think.
Yes, sir, I'm 11B.
Okay, so your final exam is on 12th Feb. Okay, okay. All right. Any doubts from the last class?
No, sir.
Okay, let's start the class. Just a second. Okay, let's solve one question. A coin is tossed 3 times. Consider the following events. Event A is no head appears. Event B is exactly one head appears. Event C is at least 2 heads appear. Okay. They're asking, do they form a set of mutually exclusive and exhaustive events? You remember what is mutually exclusive and exhaustive event?
Yes, sir.
Okay, so please solve this.
Sir, they are mutually exclusive and exhaustive events.
Okay, very good. Okay, so no need to for me to solve this.
No, sir.
Okay. Okay, so these are the set relations of probability. Okay, how we use different sets. Next is probability. We know how to write sample space, events, and everything, right, Ruchita?
Yes, sir.
Okay, so what is probability? That same thing we have been doing since we were children, right? Write it down. Definition. Write down the formula directly. Okay, we do not need the definition. Number of outcomes favorable to event E upon total number of outcomes. Okay, for an example, sample spaces head tails for a coin, and suppose event is getting a head, then probability will be getting a head. How much number is there? H, that is 1 upon total number of outcome is 2, so 1 by 2.
1 by
Okay,
2. Yes, sir.
all right. And probability is always less than equals to 1, more than equals to 0, and cannot be negative.
Yes, sir.
Done.
Yes, sir.
Okay, try to solve this question. Type 1. We'll divide the questions in few types problems based on construction of sample space. That means in every question you have to first construct the sample space, then the question is piece of cake. For an example, in a simultaneous toss of two coins, find the probability of getting two heads, exactly one head, exactly two tails, exactly one tail, and no tail. You can solve this.
Yes, sir.
Okay.
Done, sir.
Okay. When you toss two coins, then we get
Sample space
H.
as FH, HT, TH, and TT.
Very good. So
So
S
with
is
two,
this. Probability of
is
event 1. Okay. 2 hits is 1 by 4.
1 by 4. Exactly one head is 1 by 2.
1 by 2. Very good.
Exactly two tails is 1 by 4 again.
Okay.
Exactly one tail is 1 by 2.
Okay.
And no tail is 1 by 4.
What else is 1 by 4? Very good. Okay. Next question. Three coins are tossed once. Find the probability of getting one is all heads, at least two tails, at most two heads, no heads, exactly one tail, exactly two tails, a head on the first point. Okay, that is all this.
Yes, sir. Done, sir.
Okay, the sample space here is
H H H
okay,
H T H H T
HHT.
H T H
Mm-hmm.
T H H T T H T H T H T T and TTT.
Okay.
So the
So
first
now, first problem is
probability of all heads is 1 by 8.
okay.
Probability of at least two tails is 1 by 2.
At least means it can be three also, right? So 1, 2, 3, 4.
Oh,
1 by 2. Very good.
three. Probability of at most two heads is 7 by 8.
Okay. Except this, everything is fine, right? Fourth one.
Fourth one, probability of no heads is 1 by 8. Sir, isn't the third one 7 by 8?
Sorry, my bad. 7 by 8. Yes.
Probability of fifth one is exactly one tail is 3 by 8.
Exactly one tail is 1, 2, 3 by 8. Very good.
And exactly two tails is also 3 by 8.
Exactly two tails is also 3 by 8. Let's
Yes.
see. 1, 2, 3. Yes, 3 by 8.
And head on the first coin, I got 3 by 8 only, sir.
1, 2, 3, 4 by 8, right?
Okay, yes, sir.
Okay. Next one. A die is thrown. Find the probability of getting first part an even number, a prime number, and greater than or equal to 3. A number less than or equal to 4. Number more than 6. Okay. Number less than or equal to 6.
Done, sir.
All right. The sample space here is 1, 2, 3, 4, 5, 6.
Yes, sir.
An even number is 1 by 2.
Yes,
Prime
sir.
number 1 by 2. Okay.
Prime number 2 by 3, right, sir?
What are the prime numbers here?
1, 2, 3, 5. 4 by 6, which is 1, 2 by 6.
One is a prime number. Sure about that?
Ah, no, it's not. Yes, sir.
Right. In algebra, we do not count this as a prime number. Okay. Number greater than or equal to 3. So 4
2
by
by 3.
6, 2 by 3. Then equal to 4. This is again 2 by 3.
Yes, sir. 5 is 0
Okay.
and 6 is 1.
Very good. So we can also say 5 and 6 are mutually exhaustive, right?
And yes, sir.
Okay. Okay. Now we'll have some interesting questions. Okay. Problems based on combination. Combinations means that permutation combinations. Okay.
Yes, sir.
Or selections. Okay. That is a very one card is drawn from a pack of 52 cards. Each of the 52 cards being equally likely to be drawn. Find the probability that the drawn card is an ace, red, either red or king, red and a king. Okay,
Yes, sir.
you can solve this.
I will try, sir.
Okay.
Sir, can you explain the last two, 3 and 4?
Okay. So they are saying one card is drawn from a pack of 52 cards, each card of the being equally likely. That means there is no biasing in the card, okay? Equally likely. Find the probability that a drawn card is an ace. So we have 4 aces, right?
Yes, sir.
So 4C1, and we have 52 cards, so 52C1. So 4 by 52 is the first part, okay?
Yes, sir.
Second one is a red card. How many red cards are there in a deck of cards?
22.
22,
26, 26.
26. So 26C1 by 52C1. Okay.
Yes, sir.
Third one is either red or king. So whenever you have or, remember to plus. Okay.
Yes, sir.
So or means plus, that means either red, that means 26C1, or means plus a king. So how many kings are there?
4 kings.
4. But remember 2 we have already counted. Okay.
Okay, so only 2 kings then.
Yes, 2C1 upon 52C1. Okay.
Yes, sir.
And whenever you see and, that means you have to take
Subtract.
intersection. No.
Oh,
Intersection, this multiplication. Okay.
yes, sir.
So red and a king, that means only 2 cards are there which are red and a king. Okay.
Yes, sir. 2 cards.
Yes, because see, there are 4 kings, 2 in
Yes, sir.
left, 2 in right. So it should be a
Okay.
red card and a king
Yeah.
card. Okay.
Yes, sir.
So 2C1 upon 52C1. Got it?
Yes, sir.
Okay. Let's see this question you have to solve. Okay.
Okay, sir.
Next one. A box contains 9 red, 7 white, and 4 black balls. If 2 balls are drawn at random, find the probability that both the balls are red. One ball is white. The balls are of the same color. One is white and other red. Okay.
Yes, sir.
You noted this?
Yes, sir.
Okay.
So for the second one, do I add two 4C2 by something or
Two,
2C2?
two balls are drawn at random. Whenever that one ball is white. Okay. So remember this, one ball is white. That means either the first ball can be white or the second ball can be white.
Yes, sir.
Okay. And the remaining ball can be of any color.
Yes, sir.
So one ball should be white. So 7C1, and the other should not be white, right? We can say this question as this. So into,
7. Okay.
sorry.
Okay, sir.
Okay.
So 7C1 into 20C.
No, not 20. If you count 20, then that means you are counting white also, but it cannot be white.
Okay, so 13C1.
Yes.
Okay. So for the third one, will it be 9C2 times 7C2 times 4C2 by 20?
Which one? Fourth one?
The third one.
When the balls are of the same color. Okay. So same color, that means both can be white, or both can be red, or both can be black.
Black. Yes, sir.
Okay. So the answer will be 9C2 plus 7C2 plus 4C2 upon 20C2.
Okay, so what about the fourth one, sir? 7C1 times 9C1, right?
One is white and the other is red. One is white, that means 7C1 times, other is red, that means 9C1. Okay.
So when do we know when to add and when to multiply?
I told you, whenever you see or white or black or red, that means you have to add. Here they are saying one is white and other is red, that means you have to multiply.
Okay, but in the third one, or isn't there?
Right. But there is another way of writing this question. Both the balls are of the same color, that means both are of white or red
Oh,
or black,
black.
right?
Yes, sir. Yes, sir.
Okay.
The first one will be 9 by 20, right, sir?
Actually, I do not have the answer for this. We can see
9C2 by 20.
9C2 by 20C2. Okay.
Yes, sir.
One ball is white, so 7C1 times 13C1 by 20C2. Balls are of the same color, 9C2 plus 7C2 plus 4C2. And you have to calculate the complete answer. Okay, you cannot leave the answer like this.
Okay, sir.
Okay, you have to calculate the exact answer. One is white and the other is red. So 7C1 times 9C1 upon 20C2. Okay, so calculate the answers. Okay.
Okay, sir. Yes, sir. So for the fourth one, I'm getting the answer as 29 by 95.
Okay, so this is 63 by 20.
No, not the fourth
Let's
one, sir. Sorry, the third one.
third one. Okay, let me calculate the fourth one first here. 10 into 19, 190. Okay, and here we have 9C2 is 9 times 8, 4. 36 plus 21 plus 6 divided by 190. Okay, so
Okay.
this is 57, 63 by 190. All right.
Yes, sir.
All right. Four cards are drawn at random from a pack of 52 playing cards. Find the probability of getting all the cards of the same suit, all four cards of the same number, one card from each suit, two red cards, and two black cards. All cards of the same color, all face cards. Okay, try to solve this.
So same suit as in diamonds and hearts, like that, right?
Yes, yes, yes. Delete the second one. This is a bit difficult one. Okay.
So ace is not included in the face cards, right?
Yes, correct.
Done, sir.
Okay, all the answers.
Yes, sir, except the second one.
Okay, let's see. We have four cards and four cards are drawn. All the cards of the same suit. That means it can be either from the clubs, diamonds, hearts, or spades, right?
Yes, sir.
So 13c4 plus 13c4 plus 13c4 plus 13c4 divided by 52c4.
4.
Okay,
Yes, sir. Yes, sir. I
next
found
one.
the values also, sir.
Okay, very good. So this is
No,
four times. Yes, any
13.
doubts?
Sir, if in exam, if this is like a 3 mark question, is it compulsory to find all the values?
Yes.
Okay, sir.
Okay. If you are like lacking time, then like rare case that you can leave the answers. Okay, but you should find the answers. Okay.
Yes, sir.
All right.
The
Two
second
red
one,
cards. No, sorry, one card from each suit. So again,
yeah,
one from this and one from this and one from this, right?
4 into 13C1 by 52C4.
Are you sure 4 into 13c1? Because 13c1 and 13c1 and 13c1 and 13c1,
That's in, oh, okay, that's multiplication.
right? Because they are saying must be from one suit. So if you cannot
Yes,
take or, right?
yes, sir.
Next one, two red cards and two black cards.
Yeah, so 13C2 times 13C2
Not
by 50.
13c2, 26c2 times 26c2.
Yeah,
How many red
yeah,
cards are there, right?
26, yes, sir.
All cards of the same color. So it can be either red or black. So
Yeah, so
26 4.
yeah, 26C4 plus 26C4.
Very good. Upon 52c4. All face cards. So how many face cards we have?
12.
12.
Yes, sir.
So 12c4 upon 52c4. Okay.
Yes, sir.
All right. So clear about this?
Yes, sir.
Next question. Topic 3. Problems based on permutations or arrangements. If the letters of the word attraction are written down at random, find the probability that all the P's occur together. Okay.
So what's after are written?
Are written at random. Are written down at random.
Okay, sir. Sir, is the answer 1 by 5?
Okay, let's see where all the t's occur together. So all the t's occur together, that means we'll use bag method. Okay, so we put all the t's in a bag. All the remaining letters are A, R, A, C, I, O, N. Okay, so 3, 4, 7, and 8 things to arrange. So 8 factorial upon
By 2 factorial.
2 factorial. Very good. So this is total number of permutations. Sorry, number of permutations where all t's are together. Total is 4,
10
10 factorial divided by
by
2 factorial.
and 3 factorial.
So now you have to just divide this. 8 factorial by 2 factorial divided by 10 factorial by 2 factorial, 3 factorial, 2 से 2 गया, 8
10 on
factorial. So 6 upon, this is 10 into 9, 90. Okay, so 1 by 15, not 1 by 5.
Okay, sir.
Okay,
Yes, sir.
all right. So any doubts on this?
No, sir.
So you can also attempt exercises of probability. Okay,
Yes, sir.
a few more types are remaining, then this chapter is almost over. No